a very good evening to our Malaysian listeners, and also a very good morning anywhere in the world. Good afternoon, wherever you are on planet Earth. All right. So again, today, 31st of July, 2022, is our APOD presentation. APOD being Astronomy Picture of the Day by NASA. All right. So today we have our two members of our Astro Society of Penang plus me, our Miss Chu Boon Wei, all right, Akan Boon Wei, and our very young member, Rian Al-Qadri, all right, who is also present. And this time, Rian is lucky because he has a chance to present James Webb images, right? And myself, I'm Dr. Chong, and we are not able to have our usual presenter, Mr. Lai Hong Jun, because he has some other engagement. But previously, we have our airport session on the last Saturday of every month. But because of this pandemic, we started airport session in March 2020. But previously, we will have our stargazing and Kapasing Drive every Saturday. So yesterday was the time we had our stargazing in Kapasing Drive. So we were not able to do airport. So from now onwards, the future airport session will be most likely presented at the end of the last Sunday of the month in August, for example. All right. So let's start with the first picture. I'll share my screen for airport in the July this month. Boon, you can see my picture? Can huh?
Yes, I can see.
Okay, so this is asteroid picture of the day by NASA. It's very exciting, every month new exciting discovery. So we are on to July 31st. So you see, so many pictures for July 2022 and June and so on until 1995. I was following airport since 1995. All right. So now we go to the first one for which is of course the last day of this month, 31st July. Starburst Galaxy M94 from Hubble Space Telescope. So this is the picture. All right. I'll make it a bit smaller. Okay, so you can see more of the whole image. So basically, it's Messier 94, a spiral galaxy taken from Hubble, in the constellation of Canis Venatici, the hunting dog. So this it looks like a spiral galaxy. What is interesting is that it's very close to us, about 15 billion light years away. Our closest neighbor in space, the next galaxy is Andromeda Galaxy, 2.5 million light years. But this is about 15 million light years. So in terms of astronomy, it's very near. So basically, you have two, you don't see the whole galaxy here, but you look at the Wikipedia article, there are two rings. This is the inner ring, and there's an outer ring. And you see how many stars. So please don't have the wrong conception. Like in Penang, we used to give talks in Penang school. You say, what's in girl? What is, sir, inside here, there's a bright star, and there's a lot of smoke here, so the star will make the smoke light up. No. So basically, this is billions and billions of stars. There are so many stars that are so far away, they look like a cloud. But as you make it up, billions and billions of stars. So majority of the stars in this part of the galaxy are located at the bulge of the galaxy. All right. So this is it's also a starburst galaxy. That means there are stars being born at a furious rate. So in astronomy, stars being born at a furious rate doesn't mean in 1 second 1 million stars are born. No, stars take millions of years to be born, but at a rate which is faster than the stars being born in the other galaxies. So look at it, the beautiful part. So you have a lot of star here, all right, and here also a lot of stars. Right? So it's a starburst galaxy where stars are born at a furious rate. All right, as taken by Hubble Space Telescope. So you see ESA, European Space Agency, Hubble, and NASA. Of course, ESA and Hubble is also run by NASA. Right. So now I will go to the next picture presented by Rian. Rian, I'll pass over to you. Okay, you're on, Rian.
Okay, let me try to share the screen. Can you see my screen?
Yeah, I can see you, can hear you.
Okay. The first image I'll be presenting is the one for July the 25th, 2022. It's called Find the New Moon. Let me move over here. So find the new moon. Ask yourself right now, do you see any moon here?
Difficult.
Well,
No.
Yeah.
Well, it's very likely that you won't. And I'm going to explain why. But before we do that, let's talk about where this was taken. This image was taken over the Mediterranean Sea by a man named Muhammad Sultanul Kotabi. Now, what you see here is the is near sunrise. It's in very early mornings. So let's talk about the moon. We switch colors. Okay, let's talk about the moon. The
Yes.
moon has many phases. At the time where this photograph was taken, the moon was in a very small crescent phase. Now, I say small because this image was taken 3 days. Let me write that here. 3 days before the new moon. And the new moon is the time when you can't see the moon, when it's where it's completely covered, where all you see is its shadow. There's nothing to see of the moon. So this is 3 days before. So there's still the moon is still there, but it's very, very small. And at the same time, as I said, this was taken in the early morning. So if you are on the Earth here, is standing here, the moon is getting below the horizon. So there's a lot of space, there's a lot of air in between. So the light has to travel very far and it dims the light. For that reason, although the moon is in fact in this image, you can't see it. That brings me to my next image. July the 20th. Jupiter and ring in infrared from Webb. Now, before I get to this, the rest of my images will all have similar image credits. First up is NASA, ESA, and the CSA. NASA, the American Space Agency, partnered with ESA, the European Space Agency, and CSA, the Canadian Space Agency, in building the James Webb Space Telescope. And it is operated by the Space Telescope Science Institute. So you will see these four in all the rest of my images. Now, this image was processed and was licensed by Judy Schmidt. We'll get to that part in a moment. Now, ooh, wrong image. Okay, this is the right image. No, it still works the same way. NASA, ESA, CSA, Space Telescope Science Institute, but we'll go chronologically. Now, what do we see here? What we see here is a spiral galaxy. It's called Messier. Let me rewrite that. Messier 74 or M74, part of the Messier catalog. It's also called NGC 628, so it's also part of the New General Catalog. And this galaxy here, what we're looking at, is 32 million light years away from us, or around 300 million billion kilometers away from Earth. Now, though it has about some 100 billion stars in it, it is, and although it's around the same size as our own Milky Way, it's actually very dim, with what we call an apparent magnitude of 10. Now, 10 seems like a big number, but we have to remember, the higher your apparent magnitude, the dimmer it actually is. Our brightest star that we see in the night sky, Sirius, has an apparent magnitude of about negative 1.46. So here we're talking about 10. So it's very dim, which is why it's difficult for amateur astronomers to see it. But once you do, it is a beautiful sight. You get almost what we have here. Now, why is this so spectacular? Because the spiral galaxy is actually facing you. Its orientation is why professional astronomers like to use it to understand the structure and the features of spiral galaxy. And the fact that you can see two very clear arms spreading out of it is why it's called a grand design spiral galaxy. A grand design spiral galaxy. This was discovered by Pierre Mequin. He was an assistant to Messier. That's why it's part of the Messier catalog. And it was discovered in 1780. And since then, we have learned a lot. For example, we know that there are 3 supernovae that exist inside the galaxy, and there's one unconfirmed black hole that would be intermediate mass. So it has a mass of about 10,000 times that of the sun. Now, Webb's image here has also proved the existence of cooler stars and has also shown us some of the dust constructions, the structures that are in this galaxy. Now, how did it do that? The James Webb Space Telescope, in most of the images you will see today, uses these 2 apparatus. First is NIRCam, the near infrared camera. That allows you to cut through the dust and see the stars, see the galaxy itself. The next is MIRI. Oh, that's not how you spell MIRI, the mid-infrared instrument. That emphasizes the dust, so you can clearly see each of the dust structures. Now, I said I'll get back to the name here, Robert Eder. You see, with James Webb, what NASA has done is also release the data to the public. So astronomers and astrophysicists can take the data and process the images themselves. And in this case, well, it was Robert Eder who processed this image. Now I'll move on to my next image, the one I was supposed to do just now. Okay, Jupiter and ring in infrared from Webb. We just talked about how the data could be processed. Here it was processed and licensed by Judy Schmidt. Now, if you've been following with James Webb, you likely know that there were 4 images that were released by NASA. And those are considered the 4 first official released images. They were not, however, the first images Webb ever took. No. While during its testing phase, Webb had to take various images to test whether the apparatus were working. And when they looked to test whether it could see fast-moving objects, well, they looked at our own solar system. Think of it this way. You're driving at night through the city. As you drive by, the buildings pass by very fast. But the moon still stays in the sky because it's further away and it's much larger. So things closer to you move faster. Similarly, Jupiter moves faster across the sky than the galaxies and nebulae that Webb looked at. So in order to test how good Webb was at looking at faster moving objects, they pointed it at our 5th planet, Jupiter. And what do we see in this image? We see, well, Jupiter and its great red spot, the largest storm in the entire solar system. It's about 16,000 kilometers in size and is known to have existed for at least 300 years. We also see Europa. Europa was one of the 4 Galilean moons. It's one of the 4 moons that Galileo first saw. Besides Europa was Ganymede, Io, and Callisto. You also see Europa's shadow right here. This is Europa, and that's its shadow on Jupiter. Then we see 2 other moons. This right here is Phoebe, and this right here is Metis. Now, the big attraction, the main attraction here is this ring. Yes, Jupiter has a ring. Many of you are likely familiar with the fact that Saturn has a ring. But what many of you may not know is that every single planet after the asteroid belt has a ring, including Jupiter. So this is Jupiter's ring here. It was first seen by Voyager 1 in 1979. But it was only 20 years later when the Galileo spacecraft passed it that we learned how it came about. Now, what happens? Well, say we have a small meteorite, okay, and we have a moon, one of Jupiter's moons. It has to be between 1 centimeter and 0.5 kilometers in size. I know that's a big range, but that's the number. So if this small meteorite collides with this big moon, what happens? It releases dust particles. Those dust particles are what make up the ring. Unlike Saturn, which is mostly rocks and ice, Jupiter's ring is mostly made up of dust particles. And that is how it's through these collisions that the dust particles are created. Now, there's a special significance to seeing Phoebe and Metis here. Let me explain. There are 4 layers to Jupiter's rings. The halo ring is the inner. Not a good drawing, but we'll run with this. This ring here, the second ring, is what we call the main ring. The main ring. And it's usually collisions in this ring that result in more dust being added to the entire ring of Jupiter. And which moon lies in that ring? Metis. At the same time, the outer ring, furthest ring, is called the Phoebe-Gossamer ring. Why? Because when a small meteorite collides with Phoebe, the dust particles get added to that ring. So that's basically an overview of Jupiter's rings. Now, one last thing that I would like to cover that will be very important to go through in the other images too. You see these big spikes here? That is sort of a signature of Webb. You will see that 6 of them are very bright, while 2 are much dimmer. The 6 that are very bright are because of James Webb's hexagonal mirrors. The mirrors that make up the primary gold section of James Webb are a hexagon. They are shaped as a hexagon, which has 6 sides. As for the 2 smaller spikes, these are called diffraction spikes, you have the primary mirror here, and you have a secondary mirror here. That secondary mirror is held by 1, 2, 3 struts. The vertical strut creates this dim line that you see here, while the 2 diagonal struts, they are in here, but they blend in with the 6 larger spikes. Now that will be very important for us to go through with the other images. So if you have something that's very bright and focused on one point, you will get these very large diffraction spikes, very obvious. If it's spread out over a big space, like a nebulae, or in this case, a big planet, you won't see it that obvious. And if it's too small, like Metis or Phoebe here, you won't see it either. Now, my next image, APOD for July 18th, 2022. This here is a composite image, and it is of Stephan's quintet. A truly beautiful picture. Now, what is Stephan's quintet? It is the first and most studied compact galaxy group. A compact galaxy group is usually a group of around 5 galaxies. Now, here you can't see all 5. You've got 1 here, 2, 3, 4. There's a 5th one that's down here, but it's not in the frame of the image. They're all given NGC designation. So this is NGC 730. Let's make it more obvious. 7320, 7319, 7318. A, 7318. Oh, no, it's the other way around. B is on top. B, 7318. A, and then 7317 is down here. You can't see it in the image. Now, 7320 is actually the brightest of them all, but it's not exactly a part of the group because all these 4 galaxies here, including 7317, they interact with each other. NGC 7320, however, doesn't because it's actually 250 million light years closer to us. But due to forced perspective, it makes it look as if it's all part of this galaxy group, but it does not actually interact with any of the others. Now, as I said, this is a composite image. I'd actually go a little bit further and call it a composite of a composite image because this image was taken, first of all, the JWST portion was taken again from NIRCam and from NIRI. So they put them together and you get this image that we have here. In fact, I think I can, one moment. Let's see if I have an image. There we go, Stephan's quintet. This is Stephan's quintet taken from Miri. So you see a lot of dust, but not so much of the actual galaxy and the actual stars inside the galaxy. So this is Miri. This is when you take JWST and you overlay it with Hubble and the Subaru Space Telescope, then the Subaru Telescope, ground telescope, that is in Hawaii, but operated by the National Astronomical Observatory of Japan. That's why the NOAJ is credited here. And there you can see that Subaru. So Webb, Hubble, Subaru. Now, this is a prime place for us to observe something. If you look very carefully here, you can see that. Let's look at this object here. There are, again, the signature spikes of JWST, but there are these two angled spikes of, you could say, four angled spikes that are off to the side. These are from Hubble and Subaru. In fact, I have here the image taken from Hubble and Subaru. So there, this is what we're talking about. This is NGC 7317. And if we were to zoom in here, there are only 4 spikes, because that is all Hubble and Subaru have due to the way the camera and the telescope was manufactured. So it doesn't have what JWST has, what Webb has, with these 6 others. In fact, I think I can find where is it? I was able to find, there we go. This right here. You may not be able to see it so clearly, but this object is not seen in the Hubble image. So James Webb has added in a lot of new stars and galaxies, or mainly galaxies, because you don't see them with Hubble. Hubble is not sensitive enough to see them. Again, back to this page. This was processed by Robert Gendler. Now on to my last image, July the 13th.
Wow, fantastic.
Truly fantastic, yes. So fantastic, in fact, that it had its release before everyone else. This was the first image of James Webb to be released. Let's talk about it. So what is so special about this? Well, unlike the other Webb images that I've gone through with you, this one was processed solely by NASA. So as you can see here on the APOD page, there's no one else responsible for the processing. In fact, they put there that NIRCam took the image. So what are we looking at? Well, as I said, this is the first image that was ever released from James Webb. And the patch of the sky in which you see this, imagine taking one grain of sand, not a pound, not a heap, just one grain of sand, holding it out at arm's length. That is the size of this patch of sky. If you were to look into the sky, raise a grain of sand, the exact diameter of that grain of sand, as seen from that distance, is the diameter of the sky that JWST pointed itself at to see this beautiful image. Now again, what is it? Well, before I get into that, I should note these brighter objects here with the very, very clear diffraction spikes, they are stars in our own galaxy. They're not part of the main thing that JWST was looking at, which was a galaxy cluster, SMACS 0723. It has a longer name, but I'm going to refer to it as 0723 for the purpose of this presentation. Now that galaxy cluster you can see here in the center of all this gravitational lensing. I mean, look at that. Now, why is that lensing so significant? Well, the galaxy cluster itself, which is in what we call the foreground, it's light, we're seeing it as it was some 4.5 billion years ago, which is a lot. It's around the time the solar system was created. not so much compared to these other streaks of light you see here. Because of the mass, the high mass of the galaxy cluster, it does what we call gravitational lensing. It magnifies, it enlarges, it brightens the galaxies in the background, which are what we're seeing here. These redder, these fainter galaxies, they could have existed some 9 to 13 billion years ago. Gravitational lensing was the same thing that allowed Hubble to discover Earendel, the oldest star we know of now. So you see this arc? That's the same arc we're looking at here. It is a gravitational lens. The mass warps the light around it into sort of an arc, almost a circle, but not quite, just an arc. And that's what these galaxies are. And it's even possible that due to how old these galaxies are, they may very well have and contain the first stars that were ever formed. Imagine that. That's what Webb allows us to do. Now, Hubble did actually look at this image, did actually look at this patch of the sky. And as I'm embarrassed to say, this is what it saw. Back then, this was a big deal to see from what would be black and darkness in any other telescope. Hubble could come up with this. But you can still see so many black spots, so many places where it's dark, where you don't see much. And then came James Webb. The whole thing is full of background galaxies. That is the magnification power of James Webb. And whereas Hubble would have taken 2 to 3 weeks to get this image, Webb stared into a patch of sky for about 12 to 13 hours. And it got this image. Now, why does that happen? Well, Hubble, I'm going to call this Earth. Hubble orbits around Earth. So it goes around Earth. James Webb, which I'll call J for now, James Webb, is parked 1.5 million kilometers away. 1.5 million km. So it does not orbit around the Earth. It can stare into a patch of sky without being disturbed for however amount of time is needed, and definitely for much longer than Hubble. Now, this image was taken using NIRCam, but it was also analyzed by NIRSpec, the Near Infrared Spectrograph. That allows scientists and astronomers to identify how old is this galaxy? Has it collided with another galaxy? Are there stars being formed in it? It allows us to see the chemical composition, the elements that are inside that galaxy, all through this NIRSpec. Now, do I have any? That's all my images. So yes, that is what James Webb is capable of doing. Now, these deep fields, their main purpose is to study the origin of the universe. It's to study the early universe, as close to the Big Bang as possible. And as of now, Webb has not disappointed. In fact, many have been saying that it's gone and exceeded the expectations set by those who built it. So really, what Webb will discover is only a matter of time. Where Hubble has done its job, Webb is now taking over. And it's going to look even further. But Hubble is not extinct yet. They look at different wavelengths. But Webb does, in fact, see further, see more than Hubble did. And again, it's only a matter of time till we discover something new. Thank you. Dr. Chong, I'll pass it over to you.
Thank you, Rain, for your excellent presentation. Huh? Okay.
Thank you, Dr. Chong.
Yeah. So I'll share my screen now.
Trying to guarantee him a decent launch in their bid to stay ahead of the Ferraris.
It'll gain him 3 meters, let's say, off
the line in terms of the extra grip from the sole. And we know Mercedes struggles.
Can see my screen, huh? You can, huh?
They get faster warm-ups
Okay,
on that
so we are on the 24th of July. I'll show the big screen first. So basically it's Saturn, all right, in infrared from Cassini. All right, it's NASA, we know, Jet Propulsion Laboratory, Caltech, and SSI, Space Science Institute in Boulder, Colorado. Not STSCI, Space Telescope Science Institute, the one that runs Webb and Hubble. This is Space Science Institute in Boulder, Colorado, and by one guy called processed by Maxim Mekasichev. He's actually a kind of person from Estonia, went to UK. Not an astronomer, but he just processed. So basically, just look at it. I go to a smaller size now.
Within 10 car lengths of the car in front, providing your car's working fine. So that you
all right, there you are. So we know that Cassini is no more. Why? Some years ago, after its mission is completed, NASA crashed the Cassini into Saturn and it was destroyed. Right? You may say, why? Why do you want to crash it into Saturn? Because if they leave the Cassini to orbit around Saturn forever and out of control of NASA, it may accidentally crash into one of the orbiting planets, moons of Saturn. Remember, Saturn is more than 60 over moon, and they contaminate the moon by the collision. So that's why, end of the mission, they crash Cassini into the cloud tops of Saturn. Saturn do not have a solid surface, collide it into the cloud tops of Saturn. So basically, you see here, you can see the shadow of the ring on the planet. All right, and you can see a lot of features which cannot be seen in visible light. So this is our Cassini in Saturn in infrared from Cassini. So infrared, and the famous hexagon at the North Polar region of Saturn. Remember, years ago, Hubble was able to take the hexagon. So it seems until today, they are trying to understand this atmospheric phenomena in the clouds of Saturn, how it's formed. It's big, you know. The size of 1/6 of this segment here is as large as planet Earth. Alright? Remember, planet Earth diameter is about 12,000 kilometers. So you can put one whole Earth inside. So this is infrared picture of Saturn from Cassini. Of course, Cassini has done a lot of work. One of them, for example, Cassini has dropped a space probe called Huygens probe into the clouds of this Titan, and opened a parachute and landed on this Titan, the moon of Saturn, and even sniffed the atmosphere of Titan, which is made of methane, and took a lot of pictures of the surface of Titan, famous one. Huh? So this is our Saturn in infrared from Cassini. The next one is 23rd of July. Okay, this is the old information, but they put in once in a while. Our Professor Nemirov and Bonnell, they will choose pictures from the earlier mission and put in. So the Apollo 11 landing panorama. Neil Armstrong took most of this picture. Apollo 11, 1969, July, NASA. Remember, Apollo 11 had 3 astronauts that approached the moon. One of the astronauts, Michael Collins, orbited the moon, did not land on the moon. But 2 of them, our Neil Armstrong and Edwin Aldrin, detached from the command module, orbiting the moon and landed on the moon. So this is the picture of the moon before Neil Armstrong walked on the moon. All right. So you see, for most of us, like, so what? Go somewhere a desert in the Sahara Desert. But for the scientists, astronomers, they see a lot of information. So you see that it's a very dry surface, old surface, all right? And then you may say, how come I cannot see the star? Actually, if you were to stand on the moon with your own eyes, you can see a lot of stars. But remember, the astronauts have a visor, no? And I think the visors are coated with gold. Maybe you cannot see the stars. But imagine you have a transparent piece of glass protecting you from the vacuum. You can see the stars here. But why you cannot see the stars? Because the camera that took this picture is already overexposed by the bright lunar surface. Because the bright lunar surface is so bright, so the stars cannot be seen. Unless they overexpose this view, then the lunar surface is very bright, everything is very bright, then you can see the stars. But actually, it means that if you stand on the moon, you should be able to see the stars here. Remember, on the moon, you don't have a case of, let's say, the sky brightness, but on the Earth, during the daytime, the sky is bright. But during the daytime on the moon now, the sky is still dark. Because there's no atmosphere, no detectable atmosphere on the moon. So there's no light scattered by the sun. So the daytime sky on the moon is also dark. You can see stars during daytime on the moon, right? So this is it. So before he stood on the moon and said what they call one small step for me and one big leap for mankind. And this is the shadow of the lunar lander. All right. So they call it the lunar lander. And at that time they give it a name called Snoopy. Snoopy, the lander. All right. The view of the moon before Edwin Aldrin, or before Neil Armstrong walked on the moon. All right. Apollo 11 in July 1969. We go to July 21st. All right. Messier 10. Okay. July 31st. Messier 10 and a comet. Where's Messier 10? There you are. A global cluster, Messier 10. And this comet, all right, and this comet has a name here, is our comet, make it bigger so everyone can see. Comet C2017K2, Pan star. So remember the comet nomenclature. How do you name the comet? There's a certain system that was only finalized not recently. So C means that it's a non-periodic comet. That means it has a period orbiting the sun more than 200 years. Non-periodic comet. Of course, it's a periodic comet means it will orbit the sun periodically with a period of less than 200 years. Anything more than 200 years is called C, non-periodic comet, discovered in the year 2017. K2 means what? It was discovered in July. So basically, the way to discover, to name a comet is, if it's the first comet in the year 2017, it will be A1. A means the first half month in January. So A. For example, the second half month will be B. So if this is K, it means the half month of K in July, the second comet in that period. And by Pan stars. What's Pan star? Pan stars is a big telescope run by the NASA in Haleakala, a big island in Hawaii. So basically, do you know what I call? Maybe I have to look at the face. Do you know what I call Pan star? It's a big vacuum cleaner. What's a vacuum cleaner? In few days' time, you monitor the dark sky, because very, very dark in Hawaii on that mountain top. In few days' time, it will, I use the Malaysian word, sapu. It sapu all the thousands and millions of objects. Why? They are looking for transient phenomena, things that change. So, in other words, all those images that show new comets, new nebula, supernova, whatever, nova exploding, it will be able to sweep the sky. So that's why many of the amateur astronomers are not happy. Why? Because they sweep up, they vacuum up all the objects. So the amateurs are being pushed out. More discoveries are made by Pan star than any other telescope. But we hope that some of the lucky comet hunters somewhere in Japan, somewhere in New Zealand, in Malaysia, very, very determined, maybe they can still have a chance to discover new objects. So that's discovered by Pan stars. All right? The comet, yeah, and the globular cluster, all right, Messier 10. So why is it green in color? Because a lot of the comet, they will evaporate, they're called triatomic carbon. That means you have diatomic carbon. Carbon which two carbon atoms stick together by a covalent bond. So that's why the spectrum is green color. And I forgot to say that it's actually taken by an astrophotographer called, now, Malaysians will call it a German. Wrong pronunciation, German Penelas Perez. He's a Spanish guy, but in Spain it will be Herman. G becomes an H. Herman Penelas Perez, right? Just an astrophotographer in Spain that took this picture, and is in Ophiuchus constellation. Now, those of you know that Ophiuchus is the 13th constellation that passes through the plane of the ecliptic. Do you know that many people in the world are not happy, you know? They were born sometime between November and December. Technically, they are born during the time of Ophiuchus. So their constellation of the zodiac should be Ophiuchus. But because they start to 12 constellation of zodiac, the one on one side, Sagittarius, they expand it, and the other one, Scorpio, expand it to include Ophiuchus. But if you are born within that period of Ophiuchus, by right, you should be an Ophiucan, but it's not there. So in that case, you are in Ophiuchus, you're either part of Sagittarius, your constellation, or Scorpius. like this. So many people in the world still celebrate their birthday according to Ophiuchus, all right, the serpent bearer, right? So we go to the next picture. 15th of July. I like this one. Of course, a lot of the pictures we find are those scientific information. I like what? Very, very artistic. If you want to use the word, I can accept. Very, very romantic. Boon Wei, you see, so nice. So it's taken by our famous Czechoslovak astronomer Peter Horálek. He's a physicist working in one of the universities in Czech Republic, but he went to a neighboring country called Slovakia. Remember, previously Czechoslovakia was one country, but years ago it broke into two countries called Czech Republic and Slovakia. So he was from Czech Republic, Peter Horálek, but went to Eastern Slovakia, and there's an old castle called Lubovna Castle. And you see the moon, wow, so nice. You may say, but how can you?
So big.
Yeah, how can you take a picture? You know, Boon Wei, I've taken many pictures like that. How? In USM.
Really?
Yeah, like this. How to take this picture? Of course, if you know, of course, you ask CK, Chun Kia, Chiken, they all know with a telescope. So basically here said that it's about 3 kilometers from the castle. So in other words, imagine this is somewhere in the eastern sky. The moon is rising. So Peter Horálek attached a camera to his telescope 3 kilometers away from this Lubovna castle. And so in that case, if you observe, because do you know that the further away you go away from the moon, imagine you're somewhere in Malaysia, you look at the moon, you know the moon is half degree angle size. If you travel very far away from the moon, how big will be the moon look? Same, always half a degree, whatever the distance you're on the earth. But as you move further and further away from the moon's angular diameter will remain the same, but the object in front of you, this building, as you move further away, this object becomes smaller, 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 smaller. But if you are very close to this building, of course, the building is big, the moon is very small. But as you go further and further away from the moon and the building, the moon remains the same size, but the building becomes small, small, small. A time will come when the building is so small that the building is about the size of the moon. And you look at it through the telescope. You must use a telescope and you took a picture through the telescope. So nice. All right. So many people have done before, Ryan.
Okay, so now know the trick already.
You can. Well, I've done that. You know who is one of my guinea pig, Michael Teo. He stood on the School of Physics building. I was down there, but instead of the moon, he was posing in front of the sun. So you have Michael Teo like sunbathing, his silhouette covering the whole sun. Can be. So many people have taken this picture on the hill where the father and the son hold a hand, and you have the moon like that. Like this, or a boy and a girl holding hands and the moon like that. Very nice. And in addition, yeah, Peter Horálek lucky. You can see the green flash on top of the moon. The green flash. And below here, green on top and red below here. Very nice. Very artistic. I like it. So in future, please take this picture where we have done before in USM, where you have our masjid, the mosque, the minaret, and the people. So a very good thing is like this, Boon Wei. You go anywhere in Penang, you find there's a hill, and you know that a person stand on the hill, and you are about 1 or 2 kilometers down the hill, and you can see the moon or the sun rising. You take a picture of the person, which is quite big, next to the slightly bigger moon or sun. You can do it. Okay, but this is a single shot, no need long exposure, because the moon is very bright. Okay, so this is our Lubovna full moon by Peter Horálek, all right, from Czech Republic. July 13. Okay, we go to the next picture. 12th of July. Noctilucent clouds over Paris. So, of course, we English speaking say Paris. That's the way you pronounce. But you're in France, it's called, the S is silent, Paris. And there you are. This is a western sky looking back. The Eiffel Tower, of course, the city of Paris below here. And of course, near to the Eiffel Tower, you have the famous church called the Notre Dame, Our Lady there. And then you have the famous noctilucent clouds. These are about the highest clouds in the upper atmosphere. Remember, the Earth's atmosphere, the uppermost part is called 100 kilometers. Above 100 kilometers is called space. So just below 100 kilometers to about 50 kilometers from the Earth's surface, you have this noctilucent cloud. And in fact, The astronomers have done a lot of research. They're quite confirmed that actually the noctilucent clouds come from where? The presence of meteor shower. Meteor shower. So what is it? You have the particle, the origin from a comet, and this meteoroid from the comet enter into the Earth's atmosphere and burns up in the Earth's atmosphere to form a meteor. And the dust particle from the meteor will settle down, and the trillions and trillions of dust particles from the meteor shower will form the nuclei or condensation of the ice particle in the atmosphere of the Earth. So in the atmosphere of the Earth, up there is very cold, but because it's very clean, it cannot form the clouds. But you need a nucleus of condensation called a dust particle from a meteor. So the dust particle appeared from the meteor. So the ice particle, which is in supersaturated form, very cold, cannot crystallize. But now you have a dust particle, it crystallized on it to form white cloud particle, which can scatter light. And there are a lot of those nuclei of condensation. So this is that the noctilucent cloud came from the meteor shower. They produce a lot of meteor shower dust, fall into the Earth's upper atmosphere, and form the nuclei and condensation to form the ice particle. And you see the noctilucent cloud. Very nice. The other clouds of the Earth don't give this shape because noctilucent clouds are very high in the Earth's atmosphere. Right? So very nice. Huh? So we also hope we can hopefully a big bright meteor shower. What we might do, Boon Wei Rayan, with your camera, run around KL, run around Penang, see whether before sunrise or before sunset. Before sunrise means in the eastern sky, before sunset in the western sky, to see whether we can capture new noctilucent clouds in Malaysia. But I've not seen anything yet. Maybe we can see in Malaysia if you're lucky.
And then upload to APOD.
Yeah, an APOD. And then maybe Rayan or Boon Wei present a picture of noctilucent cloud that appeared at APOD, which is your picture accepted by APOD. How nice. Okay. So this is taken by Bertrand Kulik, a Frenchman, over Paris. So in other words, you can see astronomy even on the Earth's surface, all right? Noctilucent clouds, okay? So I pass away to our Boon Wei. No, I want two more, okay? 8th of July. Rules on a rotating planet. No, very imaginative, I like. But what I like is sometimes by looking at this airport, a lot of imagination. Look at it, wow. Title is The Rules on a Rotating Planet. All right, this is on our 8th of July. The rotating planet is seen where? The star trail. When you see a star trail, all right, it shows that the Earth is rotating. And you see here, on the left side here, Polaris. All right, that shows that you have the rotating planet. And what are the rules? The rules is the tree. The roots of the tree is onto the ground. So very nice. And taken by Marcella, I repeat, Marcella Giulia Pesce from Italy. She is Boon Wei, a primary school teacher. You don't expect expert as well. She just got a camera, she took a picture of the landscape. Of course, it's 137 exposure. Each exposure 20 seconds. Right? So very long exposure by a primary school teacher. So nice, all right. And basically, she's not only doing astrophotograph, but also she like atmospheric optical phenomena. All right, this is the atmospheric optical phenomena, and you see the Milky Way. Very nice, all right. And you see the star trail, all right, and you can see also the glow. So what's glow? This is taken in Sicily. So maybe some of the small towns over the horizon, there's a sky glow because of the lights in Sicily over there. So nice. I really like this type of picture. Next one, 6th of July. The one I mentioned earlier, which Boon Wei is keen to present, but never mind, you don't mind me. I explain Boon Wei. Milky Way.
I really like this photo because it looks like a Tai Chi photo.
Tai Chi, yeah. Tai Chi, or what our Boon Wei means is also our yin yang picture, yin left, yang, yin yang, and so on. So basically, it's a picture from Gaia, right? Now remember, motion, Milky Way motion in 3D from Gaia. That means from this picture here, you know that our Milky Way will rotate on its axis. Do you know, everyone here, that we are now on the planet Earth, third planet orbiting around the sun. I don't want to give the information of the planet with respect to the sun. But our sun, the whole solar system, you and me, Penang, the Earth, is also orbiting around center of the Milky Way galaxy. All right. Question: how fast are we orbiting around the center of the Milky Way galaxy? We're orbiting around the center of Milky Way galaxy at a speed of 200 kilometers per second. And because of that, you find that because your Milky Way is rotating, this blue means blue shift. All right. Red means red shift. So it shows that how the Milky Way is rotating. But you may say, wow, so much blue, huh? A lot of blue shift, so much red. No, basically it's like it's an exaggerated one. Remember, 200 kilometers per second at our distance to the center of Milky Way, our Earth is orbiting 200 kilometers per second is nothing compared to the speed of light. Speed of light is 300,000 kilometers per second. But this is they can detect with a very sensitive spectrogram that even a bit of blue shift, it can detect a slight blue shift on the left, rotation of the Milky Way, and red shift means going away from Earth, but they exaggerate it to make it like very blue, very red to exaggerate phenomenon. So this is our what you call rotation of Milky Way from Gaia. Remember, Gaia is a spacecraft sent a space telescope sent by ESA, European Space Agency, okay, years ago to measure astrometric data, meaning the exact position of this star, this object in Milky Way, and also its motion. All right, and it's still going to run until 2025. And yet, this picture they showed just now is 26 million stars in Milky Way. But the eventual aim is Gaia is supposed to sample out 1 billion objects in Milky Way. And the Gaia catalog will be tremendous catalog. So I'm sure a lot of astronomers will get their PhD from looking at studying the Gaia catalog. Look at that, so nice. So okay, and then of course, all right. To me, the first thing that came to my mind, Boon Wei, is not it is your feng shui or your what do you call this yin yang. To me, actually, this is our what do you call Vincent van Gogh painting. You know, famous European painter. He's actually from Holland. He spent his time in this what they call France to paint a lot of things called the Vincent van Gogh. Looks like a Vincent van Gogh. It looks like a bit psychedelic, right? But remember, Vincent van Gogh painted a series of the star field, the star at night over a kind of a countryside landscape. The famous Vincent van Gogh Starry Night painting, right? But this to me looks like a Vincent van Gogh painting. So nice. Oh, very nice.
Yeah, very nice.
It looks beautiful at the same time, artistically also very nice. Okay, so the next one, my last presentation tonight is 6th of July. No? Okay, it's over. I go back to the one earlier. I forgot to say. It's actually, of course, this is ISA, University Gaia. DPAC is a kind of consortium that based on the Gaia what you call data. So Atta Sarijeni is a professor in astrophysics in Florida Atlantic University in Florida. All right, he was the one who wrote this text below it. All right, short text, but very nice. So who says that astronomy cannot be represented by a kind of painting? Yes, can. All right. So I pass over now to Boon Wei. Okay, Boon Wei, you're on.
Okay, thank you, Dr. Zhang.
Yeah.
Let me share my screen first. Okay, can you see my screen now?
Yes.
Okay, so this one is it looks like actually football. Okay, so but it's actually a dome moon of Mars. So yeah, so this is a dome moon because why it is called as a dome moon, and actually dome moon is actually this is the Phobos, the Mars moon, and is actually named with the Roman god of the war. So it's somehow its meaning is the sphere, but we are say it is dome, and because it's actually considered like living and on the borrowed time, because its day is actually counted with numbers, and the fact like about 50 million years it's expected to disintegrate into a ring of debris. So why is it? Is because Phobos is actually its orbit in a very very small orbit to the Mars, and actually he completes the orbit in less than 8 hours. So if you make the calculation, right, you can get that the Phobos is actually the distance of the Phobos to the Mars is actually just 6,000 kilometer. So compared to our moon to Earth, our distance is around like 380,000 kilometers. So it's very very near to the Mars surface. So we all know that the Earth and the Moon, we have the tidal force. Like the tidal force is the force that form the tide on the sea, and it's actually the gravitational pull between the Moon to the Earth and the Earth to the Moon. So as the Phobos, it has the tide force to the Mars as well. So, but the Mars tide force is actually very, very large because it's Phobos is near to the Mars, right? So it's gradually pulling or dragging the Phobos to the Mars. So it's about like 50 million years is would likely to crash onto the Mars surface, or because of some stress, it will forming the debris and then ring around the Mars. So Phobos has another moons. I mean, discover another moon is called Deimos. It's actually originated from the asteroids from the main asteroid belt between the Mars and Jupiter. So because or maybe it's also like recent research of our solar system. And why is it so? Is should be because it is actually very small, like 11, 11 kilometer radius only. So it's actually very easy to capture by the mass gravitational pull or something. So like the big size of our moon of course cannot lah. So but it's actually you see it's a very small, right? You can see a lot of crater on the Phobos as well. So the craters are because of the crash of the meteoroid, and there was a very huge crater. It's actually this one is caught by Snickney. Is a very very large crater. Is about 9 kilometers in diameter for this crater. So it's very huge. Believe that when this I think the meteorite hit on the Phobos, it could be nearly shattered Phobos, because you see our Phobos is actually not that big and is almost taken the size already.
Mumbai, allow me to add something.
Yep.
So, Stickney is, of course, named after a woman. Who's Stickney? Stickney is the wife of the person who discovered Phobos. So, the person discovered Phobos, American astronomer Asap Hall, and Stickney is the wife of Asap Hall. So, basically, Ryan, you need not be an astronomer to have a big object named after you. The person Stickney, you are the wife of the discoverer. So, that's why I've been telling my US students for years, some of the girls, never mind, you are not here, never mind. Hopefully, you have a boyfriend and one day make a big discovery. So his first big discovery, his comet is named after himself. The second comet is named after you, his girlfriend lah. Yeah. This is Stickney, the big crater on Phobos, named after the wife of Asap Hall, the discoverer of Phobos. Okay, yeah.
Okay, so I'll go to the next photo. So is the
I really like this.
yeah, this one is a big
you.
egg. Like you can okay, this 2nd July photo is actually the can I say it's a sun chill because it's actually record the position of the sun for one whole year.
Yeah, so nice.
Yeah, it's taken this like so detail of the to record the position at the sun is so nice. So it's called solar graphic analysis. Okay, so this one is of course this photography, I mean solargraphy technique that combination of pinhole photography with the use of the photographic paper. So this photographer, David Raikabel, he actually take this photo from last year, June of 26 to this year, June of 26 in the small, I think it's a village in Poland. Yeah, at a actually fixed location.
Yeah.
So why we can see there's a figure 8 here is because we have this is actually due to the Earth rotation, and we are actually rotate with a tilt axis of 23 or 4 degrees. So if we are rotating with 0 degree tilt and also circular, we could not see this anolemma because when this is when the sun shines on and the tilted earth, so showing we have this sometimes at the summer the sun will locate at the top, and sometimes at the winter, especially in Poland, you could see the sun location is very near to the horizon already, and so that's why we have very short daytime in the winter. So these three big eight figure is actually taken on the 11 and 12 and 1 p.m. CET time. So he actually taken this um one over the year. So you see this like the sun is like from summer here and then slowly rotate to the east side. He's actually taken to facing the facing his camera to the south lah. So you can see this one is going to the west and then up to the winter and then go back to east and making a round eight. And from this how to say these groups of the dash line, right, is actually he took this is he is making his photo, the camera is actually taking the exposure made every 15 minutes, so you can see the sun rise to the sunset.
So nice.
Yeah, so the dark gap in between is actually due to we the clouds is
Yeah.
blocking the sun when he take this pinhole exposure.
Yeah.
Yeah, so
You do it for your house lah. Put a pinhole camera outside, take like that for Malaysia. Ryan, can we a pinhole camera?
uh-huh. Yeah, can try to fix, but I have to fix my camera one whole
Yeah, one whole year. Must send me lah.
yeah, one whole year and then
Yeah.
put
So
a fixed location as well, facing at the same location,
Yeah.
same direction.
How do you see? But beautiful.
Yeah,
Beautiful.
but very beautiful.
Very beautiful. Yeah.
Okay, so I would come to my last photo, and actually the first photo in July. Very beautiful planet trail. Okay, so it's a star trail and also the planet trail because you could see 7 planets in this image, and also the darker no so sorry the brightest one is our moon, and this is the reflection of the moon on the river. So this one is the forbidden city in Beijing. So this is taken by the Zheng Zhi, he's also a astrophotographer. So from this one is you could see that our planets is actually moving in actually an ecliptic orbit around the sun as well. So Zheng Ji he is actually taken the photos taking about like 3 hours long, making this exposure for like about 3 hours long.
Yeah.
And so you could see this so you could see this Saturn in this photo is almost um one to, I think, is out of the frame already. So this one is a Saturn, and the innermost one, so the first one is actually Mercury, because he took some until the sun rises, right? So the Mercury is actually rose just before the sun, and so you could actually see a very short trail of the Mercury, only because it has a very short orbit to the around the sun only, and he's actually orbiting inside the Earth's orbit. And then another one is the Jupiter. You can see Venus has a larger orbit, and is also brighter. Normally we see Venus and the Mercury is just like right before very very close to the sun, and so normally you could see is during the sunset time at the western horizon sunset, and the sunrise time is normally is near to the eastern horizon. So this is the east side, and yeah, so Mercury is very short, so you could only see this small dot here. And then Uranus, the next one is the Uranus beside the Venus. Uranus and also Neptune. Uranus is actually the first discovered planet by astronomer William Herschel in 1779 with the telescope. And then Neptune is next, the second one. So yeah, the Neptune is second one. And beside the moon, this Mars. And actually you could see because Mars is actually a red colors. So you could see the trail is also like about in red colors. And then Jupiter is a bright one. You could always recognize. For me lah, I always can only recognize the Venus and the Jupiter because it's very bright one. Yeah. So Neptune is actually is very faint, and you could only observe it when you have the aid of the equipment like telescope or something. Yep. So I think I can end this of my speak and then see anything.
We can check on the Facebook and YouTube. Any question?
Yeah, let me have a look.
No question, huh? Okay.
Mm-mm.
So one more. Yeah.
Northeast corner. I'm not the photographer. I also not so sure, but I know this one is the near east already. Yeah. Let me see anything. No. Yeah. Okay.
I just want to add one more point. Good way. You look at your picture to confirm this in Forbidden City in Beijing, China. If this is the horizon, the star trails are always at an angle. So you measure the horizon to the angle, it will be equal to the latitude of Beijing. For example, in Malaysia, this is impossible. You know how it's in Malaysia, right? Horizon, the stars and moon, all vertical one, all vertical.
So when I measure, then I can get the latitude already.
So if in Beijing it's like that lah. Australia, the angle is opposite, the other way. But right now, the moon, the star trail the planet are tilted towards the right. In Australia, it's tilted towards the left. So you measure the angle. So if someone post a picture, this is taken from let's say Romania. You check, it's not Romania. Romania latitude is different from the angle I measure. So you know that the picture is tipu. But this one is not tipu. You measure the angle, it corresponds with the angle of Beijing, the latitude of Beijing. Like that. Suppose I give you a quiz. Bunwei, I have the horizon. The star trail are always horizontal one. Horizontal, taken in winter. Where are we? Answer, North Pole. In the North Pole, in winter, no sun. But the stars are all horizontal to the surface. The star trail are horizontal. But that's the North Pole.
How about in South Pole?
South Pole, of course, South Pole is South Pole in the northern winter is a northern summer. So northern summer you cannot see lah. The sky is bright 24 hours. But South Pole in winter, in summer in the North Pole is winter the North Pole, 24-hour night. Then in the southern hemisphere you can see
Also horizontal.
So that's it. So first thing I see. So first thing when I go to China, when I go to other countries, I look at how the stars will move. Then I agree. Yes, this country is very far north of the equator, so many degrees north. Therefore, the angle is correct. Like this, yeah. Right.
Okay. Like confirm is at the northeast corner.
Northeast corner. Good, very nice. It's a big area, no? The Forbidden City, big area.
Yeah.
Yeah.
With the Forbidden City is, I'm not sure where he have the photo, but it's very, I mean, nice composition of this.
Yes.
Yeah. I see one comment is like, we are not alone. I think it's comment during the web discovery.
Yeah. Yes. Rain, any comment? We are not alone.
Yeah, we are not alone.
Web deep field.
Very likely that we aren't alone.
Yeah.
I believe it's the Drake equation that shows it's very unlikely that we are alone in this universe.
That means very certain we are not alone. A lot of ET civilization. I don't like to use alien. Alien are the bad guys. ET, the good ones.
Okay.
So, if no further question, maybe we could end our APOD session today.
Yeah. So Bunwei, you end first, then I'll add on a bit after that. You end first.
Yeah. So thank you, Dr. Zhang, and also Rayan for hosting the APOD session tonight. And so I think that's all for today, and we will see you in next month. The next APOD session in August will be also in Sunday, since we are changing the APOD date. And so please follow our Instagram, Facebook, and YouTube for the latest news and the information for our upcoming event. So Dr. Zhang, you have any add-on?
Yeah, I'll just add on. So Bunwei and Rayan, don't go away. After this, we have a short chat session among ourselves. So can you unshare first, Bunwei?
Yeah, sure. Sorry.
Thank you. Okay.
I already answered.
Okay. You can see my PowerPoint, huh?
Yes.
Okay.
Can.
Okay, announcement, the ASP, big talk is coming Saturday. Public talk astronomy in Tech Dome Penang, Saturday, 6 August, okay, 2022, this Saturday, 2 p.m. to 3:30 p.m. in Tech Dome Penang. Yeah, that's the entrance to Tech Dome, all right?
Wow, so nice.
Yeah, this is the upper floor. There are two entrances. The lower entrance where people go, this is the upper entrance. This is the entrance from the top, okay? So by our Dr. Kevin Quay and Dr. Juan Carlos Algaba Marcos, all right? So basically, the title is Sagittarius A-star meaning the supermassive black hole. First glimpse of the monster black hole in our backyard. Why is it green? Because just the first information, the first image. More information will come. Why is it a monster? Because it is a supermassive black hole. It has 4 million suns already swallowed by the black hole. In our own backyard means right in the center of our Milky Way galaxy. Right? So there's a picture. Basically, it was announced recently. So Kevin Quay was one of the astronomers in Taipei who presented it and around the world. All right. So basically, they are working on the Event Horizon Telescope. This one, a series of sub-millimeter radio telescope all around the world, the Western Hemisphere. So basically, it's organized by Tech Dome Penang, Astronomical Society of Penang, and the USM Astronomy Club. Okay, so remember in 2019, Dr. Kevin Quay gave a talk, the first image of black hole in M87, the first image. But that one is a monster upon a monster. 6 billion suns have been swallowed up. Our Milky Way is only 4 million suns. So at that time, after the talk, I think about 150 people attended. So we have the black hole sign. You saw that? Black hole sign. So this Saturday, we're going to make a black hole sign. So Dr. Kevin Quay is the fourth person from the right. All right, in the center is our Dr. Kong, CEO of TechDome. So we hope that this Saturday, don't miss it. So anyone who wants to attend it, please post your information in the Facebook of our Astro Society of Penang, because we need to get a number to inform our management of this TechDome so they can have enough seating arrangement. So if all turns good, there will be a big turnout. All right. So what else? So basically, no entrance fee will be charged for this talk, members of public. That you go in, don't say you're attending the public talk. So no entrance fee. Okay. So after that, what's the talk? So we are starting our regular stargazing. So yesterday was the third week, but last day was raining, so we couldn't see anything. So stargazing in Kampong Sing Drive every Saturday evening in Penang, 9 p.m. All right, that's all. Okay, I will unshare now. Okay, so Michael, any question? Okay, so in that case, we can end for today. We wait for the next APOD, end of August, coming APOD. All right, and we hope that our new member, Dr. Andrew Tornet in England, maybe can join us in some future. Yeah.